Alright, this is 8.1 notes, and before we start, if you hear any bells, that's part of the video, so don't freak out, that is not happening in class right now. So, 8.1 is we're starting to solve systems of equations. Right now we're doing them by graphing. So first of all, a system of linear equations is also called a linear system. It consists of two or more linear equations that have the same variables. And we'll look at examples of all this stuff we talk about up here. So that's what a linear system is. A solution of a system of linear equations with two variables is any ordered pair that satisfies all of the equations in the system. That is super important. So if I have a system of equations, of two equations with two variables, my solution is going to be the ordered pair that satisfies all of them, or ordered pairs plural. So first thing we're going to do is just determine if the ordered pair is a solution to the system. For that to be true, it has to work for both equations, and we're going to show our work on this. Alright, so for the first one, well, for all of them, to find out if this point -1, -2 is a solution to this equation, what am I going to do? To find out, we're going to just plug them in. We're going to plug in this x value and this y value to both equations to see if this point satisfies both. So let's start with the first one. I'm going to take this equation, I have -5, and replace x with -1, plus 6, replace y with -2, and this, we hope, equals -7. Well, -5 times -1 gives me a +5, and then we have plus 6 times -2 gives me a -12. And again, we hope it equals -7. Well, what is 5 plus -12? That gives me -7. So I have -7 equals -7. Is that true? Yes, it is. So this point satisfies the first equation. But we have to keep going to see if it satisfies the second. So let's plug it in. 10 times -1 minus 4 times -2 equals it equals -2. Alright, so 10 times -1 gives me -10. -4 times -2 gives me +8. We want to see if it equals -2. -10 plus 8 does give me -2. So this point satisfies the first equation and the second equation. So is it a solution to the system? Yes, it is. It is a solution. It is a solution to the system. So let's look at the second one. We're going to do the same process, plug in the x and plug in the y. Alright, when I plug in the x value of -1, I have -12 times -1 minus 4 times 1 equals 8. We need to see if it satisfies this equation. -12 times -1 gives me +12. -4 times 1 gives me -4. We want to see if it equals 8. Well, 12 minus 4 gives me 8, and 8 equals 8. So yes, it is a solution to the first equation, or it satisfies the first equation, but now we need to check to see if it does with the second one. So let's plug it in. I have my y value of 1, so I have 1 equals 6 times my x value of -1, and then minus 2. So 1 equals, well, 6 times -1 is -6 minus 2. What is -6 minus 2? It gives me -8. Does 1 equal -8? No. So this point satisfies the first equation, but not the second equation. So is it a solution to the system? No, it has to satisfy both. So it is not a solution. It must satisfy both equations to be a solution. All right, last one. I have the point 0, 2. Let's plug in the x and the y. So for the first one, I'm plugging in the y value of 2, the x value of 0. Well, 0 plus 1 gives me 1. So is this a solution to this equation? No, it's not. Do I need to go any further? I actually don't, because if I know that this point does not satisfy the first equation, then I know it's not going to be a solution to this at all. So it is not a solution. But one thing I want to address real quick. Because this point is not a solution of the system, does that mean that we can say that this system has no solution ever? No, that does not mean that. It just means that this point does not lie on these two lines, okay? So let's go ahead and talk about the methods for finding a solution. We're going to learn 3 methods for finding a solution to a linear system. The first one we are learning today, and that is graphing. Okay? So today we're going to talk about how to solve a linear system by graphing. The second one we will learn is substitution. And the third we will learn is elimination. For now, all we will know how to do is the graphing part. So we have a little vocabulary to talk about, and then we'll get working. So the first vocabulary word we have is consistent. A consistent system has at least one solution. So if my system is consistent, that means it has at least one solution. We have 2 types of systems that fall within consistent. So if my system is consistent, then it can either be independent, and that means that it has exactly one solution. So if I have an independent system, there is only one solution, and it's also consistent. Well, if I have a consistent system, it can also be dependent. And dependent means there are infinitely many solutions. And we'll look at what both of these look like on graphs in just a second. So if it's consistent, it can either be independent or dependent. If it's not consistent, then that means it is inconsistent. And an inconsistent system has no solution. So 3 different types: one solution, infinitely many, and no solution. And here is how we label them. So let's look at some examples down here and look at what they look like on the graph and then how we label them. So if I have one solution, we're going to graph some lines and look at that. So let's first graph, let's put a point at the x, our x-intercept will be 1. So put a point there, and then we're just going to use a slope of 1 here. So we'll go up 1 over 1, up 1 over 1 in both directions, down 1 over 1, down 1 over 1. So here is our first line. And I'm just giving you the lines so that we can see what these types of solutions look like. Okay, there's the first one. The second line, we're going to have a y-intercept of 5, and we're going to have a slope of -1. So let's go down 1 over 1, down 1 over 1, down 1 over 1, etc. That's going to be our second line. So graph these with me, and then we'll talk about the solution. All right, here's my system of equations. This system has one solution because there's only one point that satisfies both of those equations. Where do we see that point? It is where they intersect. So in this case, our solution is +1, 2, 3, +2. Our solution, the ordered pair that satisfies both equations, is 3, 2. It's where they intersect. How would we label this system? What type of system is this? 2 options, consistent and inconsistent. Does it have a solution or no solution? It has at least one solution. So we know it's consistent. And then with inconsistent, what type is it? Does it have exactly one or infinitely many? This has exactly one because there's only one point that satisfies both. So it is consistent and independent. That is our first type of solution, having one solution. Let's look at no solution. So for no solution, we're going to graph these 2 lines. Let's have the first one, y-intercept of 1. And then we're going to have a slope of 1. So go up 1 over 1, up 1 over 1. So go ahead and graph this line with me. And then for our other one, we're going to have a y-intercept of 5 with a slope of 1. So I'm going to go up 1 over 1, and then I can go down, left, down, left. So again, I'm just giving you these lines so that we can look at examples of these solutions. Later on in the notes, we will actually graph equations together. Okay, here's what no solution looks like. Why is this no solution? because there are no ordered pairs that satisfy both equations. If I have an ordered pair on this line, it will never be on this line. So that is why it's no solution. They do not cross ever. So how would I label this? First we ask consistent or inconsistent. At least one or no solution. Clearly this is no solution. So we would say it's inconsistent. So when I have parallel lines, lines that never cross, it is inconsistent, it has no solution. And lastly, infinite number of solutions on the line. So let's look at this equation. We're going to start with a y-intercept of -1 with our slope of 1, so up 1 over 1, up 1 over 1, etc. So let's graph that line. And if it has an infinite number of solutions, it actually means that our system has two equations that are the same. So if I'm going to graph my second one, then let's say our point, we can start here and go up 1 over 1, up 1 over 1. If it's infinite number of solutions, we actually only see one line because the equations are the same. So whenever there's an infinite number of solutions, if I'm looking at equations, the equations are going to be the same, so we're only going to see one line. Alright, so if I have an infinite number of solutions, how do I label it? Well, does it have at least one or does it have no solution? It has at least one, so it's consistent. And then underneath that, is it independent or dependent? It's dependent because it has infinitely many. So how is this different than this one? This only has one place where they intersect. But in this case, I actually have two lines that are graphed right on top of each other. So they share every single point on their line forever and ever always. So that is why there's an infinite number of solutions, because every point on this line is shared with itself. So that's why it's consistent and dependent.